All right, guys. So before we get started, are there any questions? Any questions over the homework? So everything that's been turned in has been graded and put in the grade book. So if there is not a grade on it, it's missing. Because I don't put zeros in until after the day of the test. So if there's not a grade in WinGauge at this point, it's not turned in. Now, if you just turned it in, it's still going to be considered pending because I haven't graded it. Those, but the rest of them have been graded. So we're going over 2.5 notes. So what we started on Friday, and you need the reference sheet. Yes. So the reference sheet is all the properties and postulates and theorems that we've done so far. All the stuff that we have that we can use towards our proofs and what we're proving. So we started this on Friday, and we did the first so many of these proofs. And the first one, and kind of where we left off, is this here. Because this is where we got to on Friday. Now, the notes on Friday really jumped from this, the last one we did, straight to the assignment. But this is the next part that we want to look at. Now, I have a feeling these are already filled in for y'all, or they may not be. Now, let's look at this first one here. So reflexive. We talked about the reflexive property before, A is equal to A. Now, that was the reflexive property of segment, or congruent, not congruency, reflexive property of equality, because we said A is equal to A, or this measure is equal to this measure. For this here, we're talking about the properties of segment congruency. And for a reflexive property for any segment AB is congruent to segment AB. It's congruent to itself. For symmetric, we're saying that if a segment AB is congruent to segment CD, then segment CD is congruent to segment AB. So now we're talking about the segments themselves, not their measures. So we're saying that the segments are equal, not that the lengths are. And the last one. If segment AB is congruent to segment CD, and segment CD is congruent to segment EF, then segment AB is congruent to segment EF. And we can say the exact same thing for angles. Now, this seems a little redundant. If we have it for equality, why do we need it for these here? Well, just our equality, reflexive, symmetric, and transitive properties do work, but for us to be able to use them, we have to talk about the measures. So for, say, the symmetric, for our segment congruency, AB is congruent to CD. Feel the right. To flip this just by using the equality, or to use our our equality property for symmetric, we would have to convert it to measures. Because our symmetric property of equality states that this AB's length is equal to CD's. So to use that, we would have to convert it from the segments to their lengths, then flip it, then convert it back. So this here is really just letting us say that these two are congruent and we can flip it. So we're talking about the lengths themselves. We're not talking about their measures. We can say the same thing with angles. Reflexive for any angle A is congruent to angle A. Symmetric property with angles. If angle A is congruent to angle B, then angle B is congruent to angle A. And transitive, if angle A is congruent to angle B and angle B is congruent to angle C, then angle A is congruent to angle C. That's our transitive property of angle congruence. Questions on any of this here? And these are listed on your reference sheet. So we are in 2.5 note sheet, the one that we did Friday. Mm-hmm. Also, we're on the reference sheet. These here. Mm-hmm. So this one here, we want to name the property for each one of these here that the statement illustrates. If angle T is congruent to angle V and angle V is congruent to angle R, then angle T is congruent to angle R. This would be what? Transitive property of angle congruency or angle congruence, either one. Angle congruency or angle congruence, because we're talking about angles, not segments. And we say congruency because we're talking about two things being congruent, not equal. Because if they were just equal, then it would be our properties of equality. (2.1) and 2.2. One is with angles, one is with segments. Mm-hmm. Like this part B, if JL, segment JL is congruent to YZ, segment YZ, then segment YZ is congruent to segment JL. Symmetric property of what? Because what are we dealing with? What kind of, or what is this? Segment congruence. So we can say congruence or congruency, but we're talking about segments. So we want to specify that we're talking about line segments. Mm-hmm. Questions on this here? So whenever we have segments, so they give us two segments or segments, we need to specify that it's segment congruency. If we're given angles, we're talking about angle congruency or angle congruence. Questions on this here? Okay. So here is another way that we're doing proofs, and we've done these already, two-column proof. We want to write a two-column proof for the symmetric property of segment congruence. So the symmetric property of segment congruence does state that segment LM is congruent to NP. So by definition, NP is congruent to LM, yes? So we want to prove that the symmetric property of segment congruence is true. In order to prove it, what can we not use? The segment property of congruent segments. Because if we're trying to prove it, we can't use it in the proof. And again, that's because trying to prove something and using it to prove it is just a circle. Because if I'm trying to show that someone's guilty and I say that they're guilty, did I actually prove anything? No. And that's the same with this here. We can't use this property to prove that this property is true. Now, what we start with any proof is the what? Given. We are not restricted to one given. If they give us more than one piece of information, we can list all of them out in different steps. But we're still starting with the given. Now this one was nice here. They gave us the number of lines that are needed. And we know that number 4 is going to be what? That segment NP is going to be congruent to segment LM. Now, we can't use the symmetric property of segment congruency. We can't use that. But we've already proven what? The symmetric property of equality. Because if two things are equal, A is equal to B, well, B is equal to A. We've already proven that that's true, yes? So we can actually use that here. But currently, we're saying that LM is congruent to NP, yes? If we know two things are congruent, it means they're also what? Equal. Their lengths are equal. So what we could say is that LM is equal to NP. Because when we drop the line segment above each of these two letters, we're not talking about the segment itself, we're talking about its length. Well, how did we know that they would be equal? Definition of segment congruence. Because by definition, if two things are congruent, it means that they are equal. That's just the definition. In a lot of what we do with these proofs, we're using definitions. We're using these postulates to be able to say it. And that seems like it's a little bit over the top. When do I use it? Well, when we said because the two segments are congruent, so that means they're equal. That's what? That's just the definition of what congruent segments are, yes? So that's why we listed the reason, because that's the definition. That's what it means. Now we said one of our postulates for segment equality is we can flip it by the symmetric property of equality. Because we've already proven that the symmetric property of equality works. Because we're not talking about the segments, we're talking about their lengths.
So literally all you do is just
So we're manipulating it. So any questions on this so far? Okay. Does anybody have a guess at what's going to be on line number 4? Because we're trying to go from what? Equals to congruent. Yes? Well, we know two things are congruent if they are what? Equal. If they're equal, yes? And that's by what? The definition of congruent segments here, but yeah, definition of congruency is if two things are equal, then they are congruent. That's it. Questions on this here? And again, with a lot of this, we're just using the definitions and the postulates and theorems that we've learned so far. We ready for the next one? You're good. Prove this property of midpoints. If you know that M is the midpoint of AB, prove that AB is 2 times AM, and AM is 1/2 of AB. So there's two things we want to prove this time. But before we start any proof or try to get to the bottom or the last step, we always start with what? And the given this time is, and that is given. if M is a midpoint, what do we know a midpoint does? It splits it in half into two congruent segments. Yes? What would our congruent segments be? Well, that's what we can say next. AM, segment AM is congruent to segment MB. Well, how did we know those two segments are going to be congruent? It's a midpoint. That's what a midpoint tells us, yes?
So a definition.
A midpoint. Now we're talking about lengths, yes? Okay, so we need to get to lengths, yes? Well, if we know that segment AM is congruent to segment MB, and how do we know that they're equal? Definition of congruent segments. Because if two segments are congruent, it means that they're also equal.
I get it, but at the same time, it's like my mind. It's like, you know what I mean? No?
No, I get it.
Yeah. I struggle at common sense.
Now, the first one we're wanting to prove out of the two of these here is that AB is equal to 2 times AM, yes? Well, what is AB? AB is the whole thing, yes? Have we made any statement about the whole line? No. And if we look at the statements we have so far, because M is a midpoint, yes? So from that we can say that segment AM is congruent to segment MB, yes? From that we can say AM is equal to MB. Can we take that any further than what we have? Yes. Now, what I'm getting to this here is really the first statement led to the second led to the third. Can we really take that any further than what we have? Well, no. This 1, 2, and 3 is as far as we can take that. And that's really all just extending from the midpoint, yes? Now, we need to talk about AB. We've not made any statement about AB, yes? So our next one needs to be about the distance from A to B. So we could say AB is what? AM plus MB, yes? Because if two segments add together to be the whole, is our what? Segment addition postulate. Because the segment addition postulate states if we have 3 points on a line, the two parts will add together to be the whole. So we can say what? AM plus MB is equal to AB, or vice versa. We could say AB is equal to AM plus MB, yes?
I feel like a pattern to it. Like, you know what I'm
Yeah.
So like, no, it's like easy, but at the same time, my mind is trying to wrap around how like we can just break it down to get all those things from this like one line. And so I'm like trying to break it down.
And,
Find a pattern.
and a lot of this, there's different ways to get at it. Because we could have started with the given information, M is the midpoint of AB, and jumped to 4 and said that they add together. Okay, well, then we know that they're congruent in this here. So the order can change, but I
Always be like, I will always be like, oh yeah, congruent, and then you got the like definition.
yeah, I take the first given information as far as I can possibly take it till I can't go any further. So here, M is the midpoint, so it means those two segments are congruent, which means they're equal. Okay, I can't say any more. So, okay, then we look to see, what are we trying to say? Okay, we're trying to talk about the whole segment. Okay, because of our segment addition postulate, we can say the whole segment AB is equal to AM plus MB, yes? Now, what are we trying to prove? that AB is equal to 2 times AM. Now, looking at this statement here, well, I know that MB is what? MB is equal to, so what can we do? We can substitute AM for MB. So we can say AM plus AM is equal to AB, which is our substitution property of equality, because we're substituting it in. Now, substitution and transitive are easy to get flipped. Transitive, we're taking two statements, two equations, and making them into one. Substitution, we're taking a value and replacing it. Substitution, we're taking one quantity and plugging it in or replacing it. Transitive, we're taking two statements and making them one. Yep. And that's why we gave you, or I gave you the reference sheet. It's going to also be included on the review sheet. I will also include one in the review. Well, I have a feeling they probably put something a little different, but AM plus AM is 2 AM, yes? Let's see what they said. Distributed property. Simplify. Now, we can really say it's the distributed property. We're working backwards. We're saying that we factor the AM out, and then 1 plus 1 is 2. I'm going to say simplify. Now, what was the other statement we wanted to prove? That? Which would be our other one, yes? So what can we do to go from 6 to 7? We can divide both sides by 2, which is just our division property of equality. Questions on this here? Are we ready for the next one? Because this here is the last proof we have on this here. So we want to write a 2-column proof. So we can make a little T-shaped chart just so we can split the two sides apart. I use the computer to do it for me. The easiest way to draw a straight line is if you put your pen where you're starting or pencil where you're starting, and instead of watching it, you look at where you're going. You can actually draw a straight line easier. Yep. Because if you follow the pen, your hand's going to try to adjust for it. So, all right, guys, let's look at this here. So we start with the MP bisects angle LMN, and this is our given. Because we always start with the given. Now we want to prove that 2 times the measure of angle LMP is equal to the measure of angle LMN. Now if we know that MP bisects the whole angle, we know that those two angles should be what? Congruent. So we know that angle LMP is congruent to angle PMN. Now we could have named them, instead of LMP, we could have named it PML, or instead of PMN, NMP. Those are the same. The definition of angle bisector. Because an angle bisector cuts an angle in half into two congruent angles. So just the definition of angle bisector says that these two angles should be congruent to each other. If the angles are congruent, it means that their measures are equal. So we can say the measure of angle LMP is equal to the measure of angle PMN. Definition of angle congruency. LMP is equal to PMN. Now, just like the last one, we can't take that any further because we said that they're equal. That's good, but we need to what? We need to talk about LMN, because the measure of angle LMN is equal to, well, I just ran out of room. Not yet, but going to. Is equal to the measure of angle LMP plus the measure of angle PMN. Because we know that the whole angle is equal to the sum of its two parts. And we know this because of our what? Angle addition property. Because the angle addition property says that the whole angle is going to equal the sum of the two smaller ones. Because we don't need those properties. Because otherwise I would have to cut all that out and then reattach it into a new paper. Yeah, you're good. Now, let's look at this next step. Step number 5. Now, we know that these two measures are the same. And we're wanting to state that we have 2 times LMP.
So now we do the substitution.
Yes. So we can say that the measure of angle LMN is equal to the measure of angle LMP plus the measure of angle LMP. Substitution property of equality. Because what was our final proof? 2 times the measure of angle. The book will probably say distributed, but I will take either.
Measure P times 2.
Any other questions on this here?
On the bottom one, on number 6,
Mhm.
what does it say?
The measure of angle LMN is equal to 2 times the measure of angle LMP. If we wanted to, we could have said, proven that from here, that half the measure of angle LMN is equal to the measure of angle LMP. But we're not going that far. And this here is kind of just what we've been doing, a two-column proof. Because we have our statements that we're doing. Now the number will vary, but the last statement is always what we're wanting to prove. We have our reasons, our given definitions, postulates, or proven theorems, and we list it out here. And that's it. Yes, sir. Yes.